All right, well, let us talk about your exam tomorrow. So you have an exam tomorrow, as I'm sure you're all aware. I will say the layout's going to be pretty straightforward, right? Like she is giving you 4 practice tests and the structure of the midterm. You should know what to expect, right? There's going to be a piecewise function where you're asked to do a bunch, right? You're going to have to graph it, find the limits, find the domain, find the range, find all the points where it's continuous. There's going to be finding an inverse. There's going to be 7 limit questions, each worth 5 points. There's going to be semi-log and log, which I think we're going to start with today, actually. There's going to be both finding the general term of a sequence, and there's going to be finding the limit of a recursive sequence. It'll almost definitely exist. And then lastly, there's going to be the thing we have to maybe right, there's no surprises. There might be some limits that are a little different than what you've already seen. There really shouldn't be any surprises on your exam tomorrow as far as the content. So let's talk about the kinds of things we might see. And I actually want to start by talking about log versus semi-log, because it's pretty straightforward if you know what to do. So I just want to point out, here are the practice tests she gave with the log and semi-log. So looking at this practice test, and let's zoom in a little bit for a minute here. Sorry, I didn't actually mean to zoom in like that, but whatever. So let's brighten this up actually a little bit. Sorry, 1 second. Okay, so looking at this one, where this is the semi-log graph, this is the log graph, which one should we be picking? The log, right? The one where the graph fits all the data points. And in this one, we should be picking the semi-log because that's the one where the graph fits all, right? So if she gives you one that's graphical, it should be obvious which one to pick. It's the one where the straight line actually goes through all the points, not where it's off on some of the points. Additionally, I'll point out that the exam she actually gave last quarter, the question is in words, right? She didn't actually give you a graph. She literally told you it was log. So I think it's going to be relatively easy to identify whether or not it's log or semi-log, but then what to do with that. So I can kind of think of 4 different ways someone might phrase this question, and we'll go through them fairly quickly here. So let's say we're given the following. Suppose, and so we're just going to get to the chase. So suppose population, etc. Right, you should be scanning this question and looking for the word, is it log or semi-log? So when we plot on a, we'll do semi-log first. On a semi-log plot, we're given the following information. A straight line with a slope of negative 2.3 results. Okay, there's 2 different ways of phrasing this next part. We'll do both of them. So I'm going to phrase it like she did in the problem here. Furthermore, assume the population at time 0 is 20. What function, etc., etc. Okay, so here are the things to zone in on, right? First, semi-log, great. Slope is negative 2.3. Population at time 0 is 20. So with semi-log, I'm going to start writing this. Log of y equals my slope times x plus b. I would actually probably just plug in the values, to be perfectly honest, but that's where you would start. Semi-log means 1 log and 1 not log, and the log should always go with the y. Right? Y should always have a log. X may or may not. Log, it's going to be log of x and semi-log. So then we're going to actually plug in the values. Log of y equals negative 2.3x plus, not 20. And here's why. When we say that the population times 0 is 20, it means that the population y equals 20 when time equals 0. But if I write 20 here, it's not true that y is going to be 20 when time is equal to 0. So what I actually maybe should have done first, and there's a couple different ways to go about this. I might go over here first and say, okay, well, if I plug in 20 for y and time equals 0, or x, I used x, people use time. If x or time is 0, that part's going to be 0, and you're going to get log of 20 equal to b. So that's actually what we're going to have here, is log of 20. Sorry, the rest of it is solving for y. We know if it's semi-log, we should end up with something that looks exponential, meaning you end up with x in the exponent. Versus if it's log, we know we should end up with a power function where you end up with x raised to a power. So let's see what happens here. I'm going to raise both sides to as powers of 10. This is going to be 10 to the log of y equal to 10 to the all of that. Negative 2.3x plus log of 20. You're short on time, I would stop here. Y equals 10 to the negative 2.3x times 10 to the log of 20. That's totally actually correct. It's just not as simplified as someone might like it to be. But this is a correct answer. And if you're right, if you want to spend more time doing other stuff, this is a perfectly fine place to end. If you want to make it look nice and fancy, 10 to the log of 20 is 20. And so I would rewrite this as y equal to 20 times 10 to the negative 2.3 to the x is 10 to the negative 2.3 to the x. This is the more simplified way of writing it. Notably, if I plug in 0 for x, something to the 0th power is 1, and 20 times 1 gives me 20, like they said we should get when we plug in 0 for t or x. Operations should be 20. Question? Let me answer your question with a different question. So we're going to do another example, and then we'll circle back to that question. Okay. Other questions about this before we do another example that's similar but different? So let's say we had a similar situation, but now we're given, so again, the usual setup. We are given, it's the plot on a semi-log plot is still a straight line. It's always going to be a straight line. With, now let's say the slope is positive 9.7 and a y and I'll say a vertical axis intercept of 4.1. This is where they're giving you the b value right off the bat. So it's still semi-log. We have a slope of 9.7. And now our b value is 4.1 because they're telling you that when you graph this thing on a semi-log graph, you're getting something where the slope is 9.7. And this intercept here is 4.1. So we would still set this up almost the same way. I guess it feels slightly different maybe. But we're going to start off with, again, semi-log. So log of y equal to my slope times x plus my y-intercept. I should say my vertical axis intercept. Not really my y-intercept because it's my log of y-intercept. And then we would solve this in the same way. 10 to the on both sides. On the left-hand side, you get y. On the right-hand side, you get 10 to the 9.7x times 10 to the 4.1. And really, the only thing I would do to make this look quote unquote simplified is to write it as 10 to the 4.1 times 10 to the 9.7 to the x. Again, this is kind of emphasizing the exponential nature of our results. So to go back to your question, Kyra, the reason why we used the log here is because they didn't tell us what the vertical axis intercept was. They told us that when t or x equals 0, then y equals 20. But if I put in plus 20 right here, that's not right. Back, let me write it over here. If I were to write log of y equals negative 2.3x plus 20, I'm not going to actually get that y is equal to 20 when x is equal to 0. Because if this is 0, then I'm going to have log of y equal to 20, which actually means y is much, much larger. Y is equal to 10 to the 20th power in that case. It's a very different thing. So you have to be careful when you read these semi-log or, log questions. If they tell you the y value or the population value, they're not telling you the b value. They're not telling you the intercept of your straight line. They're telling you have to use more information. And we'll do two more that kind of get it with the log situation. Other questions about either one of these first two examples? For the previous one? Oh, this is the answer right here. Sorry. Oh, we can. Sorry. Yes, you can see it. Sorry. I'm like, I can see it right here. It's right there. There it is. Also, Daniel, feel free to ask questions if you got them. Okay. So, in either case, semi-log, we expect our answer to have a something to the x in the end. It always be exponential. 10 to the something to the x or 10 to the something to the x. Basically, if it's semi-log, it should always your thing should look like something times 10 to the slope to the x. So it's always going to be. On the other hand, let's see what happens if they give us a log situation. So now the population is log, or is, sorry, I'm not using the appropriate language. It's when we plot the data on a log, when we plot on log graph, we get a straight line with a slope of m equal to, I'm just making up numbers really, 3.4, and a, let's see what language your teacher likes to use. No, that she actually doesn't. Interesting. Hasn't really come up. Just trying to see what she's using here. No, yeah. So for the log, you're almost always given the vertical axis intercept. So vertical axis intercept of 6.3. Find the relationship between the population and time. So again, well, not again, somewhat differently, we know it's log. Slope is 3.4. The b value or the vertical axis intercept is 6.3. So we're thinking log of y equal to m times log of x plus 6.3. The process is very similar as to the previous problem. We're just going to get a slightly different result. You're still doing the same work though. You're going to write both sides as powers of 10. So you're going to say 10 to the log of y equals 10 to the all of this. 3.4 times log of x plus 6.3. Let's do one step of simplification first. You should definitely, if you're doing this problem, you should certainly write 10 to the log of y as just y. That's definitely something you should do. Y equal to, and here we should definitely break this apart as 10 to the 3.4 times log of x times 10 to the 6.3. And technically this answer is correct. You could totally leave it here and say, I'm done, I'm going to move on. If you've got more time, you should really do the following. This 3.4 can come up as the power there. So we can really write this as 10 to the log of x to the 3.4 times 10 to the 6.3. And then 10 to the log of some stuff is just the stuff. So we can really write this as y equal to x to the 3.4 times 10 to the 6.3. And then I would probably put the number in front just because that's more typical. So I would prefer to write it like this: 10 to the 6.3 times x to the 3.4. And that is a power function, right? Our result is x raised to a power, not something raised to the x like in the previous two semi-log examples. With semi-log, you expect your function to be something with x as the exponent. If it's log, you expect your function to be something with x raised to a numerical power. That numerical power should be whatever the slope is. Let's do one more example that I don't think is going to come up, but you never know. People like to change things up on an exam. So I thought of one more way I could phrase this. We'll do one more log. So let me try and write the phrasing semi. No, okay. Wasn't that funny, I know. So one more example here. Suppose that population, when plotted on a, and I'm going to make you guys try this one, on a log plot, is once again a straight line with a slope of, say, 1.95. Furthermore, this is where it's going to be interesting. Bless you. The population size is 40 when time equals 1. But use x. Find the functional relationship. I'll help get you all started. You should be starting with, well, they told us log. It's going to be log of y equal to m times log of x plus not 40. Here's what I'm going to say. To find b, plug in y equal to 40 and x equal to 1. Find you log of 1 is equal to 0. Was strange. Oh, it's an update. Okay. Go away. Right. All right, let's take a look. I will actually point out, you don't have to find B right away. You could totally wait till the end if you wanted to. I'll show you both ways. So one way would be to just plug in 40 for Y and 1 for X. The log of 40 equals 1.95 times log of 1 is 0 plus B. So then B is log of 40. So then you can do the usual work. Did I leave myself enough room? Probably not. Log of Y equals 1.95 log of X plus log of 40. That was a little sketchy there. Yeah. And then 10 to the both sides. So 10 to the log of Y equals 10 to the all of that. 1.95 log of X plus log of 40. And then break it apart. So you get 10 to the log of Y is Y. 10 to the 1.95 log of X times 10 to the log of 40. And then 10 to the log of 40 is just 40. And 10 to the 1.95 log of X we can write as 10 to the log of X to the 1.95. We end up really with just getting 40 times X to the 1.95. And maybe you just don't like doing that thing where you find B weirdly first. You don't have to. If you really wanted to, you just say, well, I've got log of Y equal to 1.95 times log of X, and I'll deal with B at the end. It will work. So 10 both sides, or 10 to the log of Y equals 10 to the 1.95 log of X. Let's just say times 10 to the B. And then 10 to the log of Y is just Y. 10 to the 1.95 log of X is just X to the 1.95 times 10 to the B. And now when I plug in X equal to 1, I get Y equal to 40. So I've got 40 equal to 1 times 10 to the B. Well, 10 to the B better be 40. So I definitely get Y equal to 40 times X to the 1.95. I didn't even really ever find that B was the log of 40. I didn't have to. So log, semi-log. They're going to give you the slope. You're going to have to identify it, or they will tell you if it's log, or semi-log. And then if they tell you what the vertical axis intercept is, that's just what goes there. If they tell you what the population is at time equals 0 or time equals 1, then you have to plug those things in and make sure that you get the right things coming out. At the very end, if your answer is this, I should be able to plug in 1 for X and get 40 for Y. Or in the very first problem we did, at the very end, I should be able to, since the population is 20 when time is 0, I should be able to plug in 0 for X and get 20 times something to the 0 is 20 times 1, which is 20 for Y. Any questions about this before we move on to other things? Okay, it's going to be on your test. You know what to expect. This should be straightforward. All right, let's move on to other things. Let's see, what did I have up next? Oh, I should pause. I wanted to get through that just to make sure I did that. But I will say, if there are any specific questions from any of the 4 practice exams, I'm happy to address them. You just need to let me know which exam and which question. Shereen, did you still want me to go over those too? Okay. So I'm gonna actually I'll come around to those questions. But you also think about it. I'm gonna do a continuity problem first, and then we can talk about other questions. Welcome, Lily. Do you have a calculator on the test? Excellent question. I don't know. Do you all have a calculator on the test? The big no. You probably shouldn't. It shouldn't be too terrible without one though. So I feel like the numbers are mostly not terrible. Let me grab a couple examples here, but certainly I will address questions from the practice exams if you have them. Let's look at. Yeah, I wanted to look at this question I came up with, and then we can get going. So let's say we have the following. Your function f of x is -1 over x plus 4 when x is less than -2. 3 when x is equal to 2. Square root of x. Oh, sorry, -2, apologize. When x is greater than -2. And it's going to be the usual thing where we're going to be asked to graph it, find the domain, find the range, find where it's continuous. Oh, and find a couple limits as well. And we'll start with the limits. And here's what I would say. I would say the order you should really probably do things in is first deal with the limits, then deal with the domain, then deal with the graph and range and continuity afterwards. You probably do those either way. That's what I would do. The limits are almost always going to be about what's happening at the place where you change from one piece of the function to the other piece of the function. So we are definitely concerned with the limits as x approach -2. So the limit as x approaches -2 from the left. All we are required to do, we're not graphing it yet, although you totally could graph it ahead of time. If you like graphing it first, you should do that. If you don't like graphing it first, I would do this. Okay, x approaches -2 from the left. That means x is less than -2. I'm gonna look for that piece right there where x is less than -2 and say, okay, well, I can just plug in -2 to my function. So I'm going to get, and I would write this is the limit as x approaches -2 from the left of the piece I'm using, which is -1 over x plus 4. So plug in -2, get -1 over -2 plus 4, which is -1 over 2. So there's my limit from the left, -1/2. On the other hand, the limit as x approaches -2 from the right, I get the limit as x approaches -2 from the right of the square root of x. Square root of x isn't defined just to the right of -2. It is eventually defined, but if you look immediately to the right of -2, like -1.9, -1.8, you can't take the square root of a negative number. So this limit does not exist because square root of x is undefined if x is less than 0. And it certainly is if we're approaching -2 from the right side, or from any side of -2, really. And then overall, if the limits don't match up, or if one of them doesn't exist, then the overall limit does not exist. And personally, next, I would think about domain. So I think one question that has been throwing people off with this kind of question a little bit is this function defined at the place where we're changing from one piece to another? Is this defined when x is equal to -2? And it for sure is. What's f of -2? If I plug in -2 to my function, I get 3. It's just given to you. So that's not answering this question, but just to point out that -2 is for sure in the domain of this function. This function is well defined there, not a problem. So the places where it's undefined, well, it's certainly undefined when x is equal to -4, because you get 1 divided by 0. And it's also undefined for the square root part of the function when x is negative. So the square root of x, well, when x is between 0 and -2, that function is definitely undefined there. It might, I will certainly say, it might be better for someone to graph first. I don't personally like it, but I'm not everyone. So here, our domain is everything from -infinity to -4. And then everything from -4 up to -2, inclusive. Right? We get to include -2 because this function is definitely defined at -2. But then just after -2, it's totally undefined, right? The square root is undefined until you get to 0. And then the square root of 0, and any positive number is certainly well defined. There's our domain, kind of funky. To me, that feels like enough information to maybe start trying to graph it. So let's see what we've got here. I know for my function here, I'm going to have a vertical asymptote at -4. That's probably the first thing I would actually graph. Okay, there's a vertical asymptote at -4, and I know at -2, it's defined to be equal to 3. It's going to be kind of a lonesome point up there. And then, okay, -1 over x plus 4, that kind of looks like your usual 1 over x graph, except kind of flipped over, right? 1 over x looks like this. -1 over x looks like this. So it's going to have that shape, but shifted 4 to the left. So it's going to do something kind of like this. And it's going to come up this way until I get to -2. And we already saw the limit as x approaches -2 from the left was -1/2. So now when I get to this point right here, I'm getting to, now my scale is not very good, I apologize. A value of -1/2 there. And again, yeah, I know it looks not the best. And then you get nothing between -2 and 0. It's just a barren desert of nothingness. And then once you get to 0, we got the square root function. I keep going off page here. And so we're starting here, then you get your square root function that looks like that. A little weird. But that's our function. Questions about this function so far? It can't. What's the square root of -2? Right, it's imaginary, it's undefined. We can't graph imaginary numbers. So you can't start the square root part of the graph until you get to 0. Just like for the one of the practice ones, you can't start the natural log of x minus 3 graph until you get to being just a little bit bigger than 3. So yeah, wow. Well, because, so that's a really, really good question. So if you're coming at -2 from the right, you have to get up close and personal to actually -2. When I get really, really close to -2 from the right-hand side, there's just no function there to plug into. So that's why we're not getting 0. You're correct in that the function is defined to be equal to the square root of x when x is on the right side of -2, but we don't actually get to start that until you get to 0.
So if it was like x is greater than or less than 0, then
Totally, yeah. In fact, there is one of the on one of the practices, it does start like it gives you a square root of x function starting when x is greater than 0. And the limit from the right certainly is equal to 0 because you're getting closer and closer to 0. But here, there's no function to follow along with it where we're getting closer and closer to any particular value. Okay, let's answer the last couple of questions here. We want to talk about the range. So for range, we're really just kind of stuck with looking at what this is doing. And you know what? I said, did I do this backwards? No, that's fine. It just looks backwards to me for some reason. I meant for this not to turn out this way. Oh, well, such is life. So looking at range, I'm thinking y values. So I'm just kind of starting, okay, how low do my y values go? It looks like they go as low as -infinity. My y values are going as low as -infinity, and they're going up to almost -1/2. But then there's a gulf between -1/2 and the next y value, which is 0. But then I get everything from 0 onwards. Sorry, that looks terrible. Apologies. So here I'm getting everything from -infinity up to -1/2, exclusive of -1/2. I don't actually get that value. It's a hole right there. And then from here onwards, I start at 0 and I do get 0 because that point is filled in right there. So I get everything from 0 all the way up to forever and ever and ever. My range here is negative infinity to negative 1/2 with a parentheses, union bracket 0 to infinity. And for continuity, I'm just going to look at my graph and see where do I not have breaks? So for continuity, well, everything, and so continuity rate range, we're talking y values, domain and continuity, you're talking x values. Important note, anything that's not in the domain cannot be a place where the function is continuous. So we already know for sure that it's going to be continuous within whatever our domain was. So this is the largest place where it could be continuous, but it's definitely not continuous everywhere there. It's going to be discontinuous at -2 for sure. The limit as x approaches -2 doesn't exist. And there might be some other spots. Let's see here. So I see continuity everywhere from negative infinity up to -4. And then everywhere from -4 up to, well, continuous until I get to x equal to -2. It's definitely not continuous at -2. Oh, sorry, you can't, I keep pointing to the graph like you can see it. Sorry. Continuous, so continuous when x is less than -4, continuous here when x is between -4 and -2. And now, where's the next place where the continuity starts again? Yeah, and here's maybe a weird question. Do we include 0 or not? And the answer is we do. It is considered to be continuous at 0. And the reason it's considered to be continuous at 0 is because it looks like it is. And if it's not defined on one side, we define continuity to be a one-sided continuity. So technically at 0, this function is continuous from the right. Because the limit from the right, as you approach 0, is 0, and the function is defined to be 0 at 0. And from the left, immediately to the left, not defined, so we don't worry about it. I know it's not everyone's favorite definition. It's not my favorite definition, but it is actually what we say. So in a similar way, I will just point out, just so you all are aware, if your function was just the square root of x, which looks like just this, we would say it's continuous on the interval from 0 inclusive to infinity. Because it is continuous, looks continuous, and immediately on the other side is 0, not defined at all, so we don't worry about it.
Also in the numerator, so it's greater than and equal to 0. That's why.
Well, so again, we don't worry about being greater than 0 or less than 0, whether you're in the numerator or the denominator. Being non-negative is specifically a quality that's necessary for when something is inside of a square root, or being positive is necessary when something is inside of a logarithm. Doesn't matter, numerator, denominator, whatever. If I'm looking for square roots and logs. I'm looking for stuff being positive. Someone asked, don't quite understand the difference between domain and continuity. So let's look at the graph to kind of see it. So here on this graph, this function is defined as a domain everywhere except for at x equal to -4. Definitely doesn't, right? The function does not exist there. X equal to -4 is not in the domain. And everywhere between -2 exclusive, right? -2 is in the domain because the function is defined to equal something when x is -2. But everywhere to the right of -2 and to the left of 0, this function is also undefined. So in this problem, the only place where it's undefined is -4 and the interval from -2 exclusive to 0 exclusive are not in the domain. Notably, -2 is in the domain. On the other hand, this function is wildly not continuous at -2, right? The function is defined to be up here. You've got a limit from the left. You don't even have a limit from the right. But according to the definition of continuity, right? The limit has to exist. Okay, we failed that one. Function has to exist. Okay, and the limit and the function have to equal each other. But the limit not existing means it's definitely not continuous. Or as you might say, if you're actually drawing the graph, okay, here's my graph, drawing. At -4, lifting my pen off the paper, discontinuous. Putting it back on the paper. Okay, from -4 onwards, continuous, up. Lifting my pen off the paper, discontinuous at -2. Drawing that point. Lifting my pen off the paper again, going all the way over to 0. So it's totally discontinuous between there and there because I didn't draw anything. And then from here onwards, continuous again. So hopefully that helps a little bit with the difference between continuous and domain. Domain is just wherever the function is defined. Continuous is wherever we can draw it without lifting our pencil off the paper. As a layperson way of kind of saying. Other questions about this? Okay. I've got some other examples I want to get to eventually, but let me ask, are there any specific questions from any of these practice exams you would like me to get to? Yeah, Dana. Sorry, say that one more time. Sure. Which exam? Okay. Sure, yeah. Let me look at them. All right, so midterm 2, 3. That's 1. Okay, this must be 2. Okay, practice midterm 2. Which one? Sorry, say that one more time. 3A. Cool. 3 is the 3. Sure, limits, yes, and we can definitely talk about limits. So 3A. So the limit x approaches 3 from the left-hand side, 2 divided by x plus 1 over x minus 3 squared. I feel like this one's a little misleading, but probably purposely. Normal, well, no, I don't know. How would I say this? I would always start with doing what? Plugging it in. So if we plug it in, we get 2/3 plus 1 divided by, 3 minus 3 is 0. So when I get a 0 in the denominator and it's not a 0 in the numerator, I do a little bit more thinking. I'm like, okay, well, it's a 0 in the denominator, but is it slightly negative or slightly positive? Well, I'm on the left side of 3. So I'm slightly less than 3. And slightly less than 3 minus 3 is slightly negative. But it's squared. So what I have here is 2/3 plus a very, very, very large positive number. I know it's large because I'm dividing by something small. I know it's positive because it's a negative number squared. And I have a positive on top and a positive on the bottom. It's 2/3 plus positive infinity, which is infinity. And I don't imagine that there's really any other work your teacher expects you to do for a problem like this. When you're getting not 0 divided by 0, it's usually going to some sort of infinity or negative infinity. Your job is just to determine the sign. As an additional kind of look here, if instead the question was the limit as x approaches 3 from the left of 2 over x plus 1 over x minus 3 cubed, then we would still plug in. We would get 2/3 plus 1 over, now a number less than 3 minus 3 is still slightly negative, but the negative number cubed is still negative. So this ends up being 2/3 plus, instead of very, very large positive number, very, very large negative number. And 2/3 plus negative infinity, or 2/3 of minus infinity, is negative infinity. So when you get not 0 divided by 0, even if there's some other dumb fraction out in front here that is a regular finite number that's a fraction, then you have to say, okay, well, it's going to be plus or minus infinity. My job is to determine whether it's positive or negative. Now I should contrast this with, that one. So on the same practice exam number 2, this is definitely in contrast to the following question, 3E, which is the limit as x approaches 0 of 1 over x times the square root of 1 plus x minus 1 over x. These problems are similar, but not at all the same. If I plugged in, which I should still think about doing every time, I'm going to get 1 over 0 times 1, which is 1 over 0 minus 1 over 0. And I don't really know if these are positive or negative because I'm not approaching 0 from any particular side. But here's the thing. This is 1 over 0 is some sort of infinity minus some sort of infinity. I'm not going to get too into the specifics here because it's a little weird. But generally, if you have infinity minus infinity, it's a lot like 0 over 0 or infinity over infinity. If you see any of these sort of things, and you will definitely see a 0 over 0, you will probably see infinity over infinity. And if you happen to get unlucky and see infinity minus infinity, all these things mean one thing. You know what it is. Do more work. Do something. You have to do something. You can't just be like infinity minus infinity is 5, or infinity minus infinity is infinity, or infinity divided by infinity is 1. It might be, but it's probably not. It's probably something else. So all these things mean do more. Usually do some algebra. In this case, when you're subtracting fractions from each other, getting a common denominator is the way to go. Fortunately, it's not too terrible. Here we're going to get the limit as x goes to 0 of 1 over x times the square root of 1 plus x. Well, I've already gotten x in the denominator here, so I don't need to multiply this by x over x, but I am going to multiply the 1 over x by square root of 1 plus x over the square root of 1 plus x. Now, if I look at this, I've got the limit as x goes to 0, 1 minus the square root of 1 plus x over x times the square root of 1 plus x. And then I should maybe check if I plug in 0 now. Do I get anything good? No, I get 1 minus 1, which is 0, over 0 times 1, which is also 0. I still get 0 over 0, so I keep doing more work. And the work I should do now is to, yeah, good, excellent. So 1 minus square root of 1 plus x times the square root of 1 plus x, I'm going to multiply by 1 plus the square root of 1 plus x over 1 plus the square root of 1 plus x, the conjugate. I'm going to end up getting on top, let's see, 1 times 1 is 1. The middle terms cancel every time you multiply by a conjugate, and I get minus the second thing squared. Now be careful here. I imagine this was done with intent. You have to make sure it's minus the entire parentheses 1 plus x. Because that just minus sign has to distribute to each thing in the top there. Divided by, don't multiply at the bottom, x times the square root of 1 plus x times 1 plus the square root of 1 plus x. On top, if we distribute the minus sign, we get 1 minus x, and the ones cancel, and we end up with the limit as x goes to 0 of negative x over x times the square root of 1 plus x times parentheses 1 plus the square root of 1 plus x. And finally, I can cancel the x on top and the x on the bottom and leave myself with a negative 1 on top. So I'm going to have now the limit as x approaches 0, negative 1 over the square root of 1 plus x times 1 plus the square root of 1 plus x. And now that I've finally canceled the thing that was giving me a problem, I can plug in 0 and get negative 1 over the square root of 1 times 1 plus the square root of 1, which is really negative 1 over 1 times 2, or negative 1. If we'd missed that minus sign distribution there, we would have definitely gotten positive 1/2 instead of negative 1/2, which I would imagine would still count for a decent amount of partial credit, but we want all the points we can get. So yeah. So again, this one was also a non-zero divided by 0, but since there were 2 of them together, we didn't really do the usual thing where it's like it's infinity or negative. Other practice exam questions you would like me to address? Yeah, sure.
I think it's like this is E.
Uh-huh.
There's like one below that.
F the 3x plus 5 over, yeah, sure. We'll do that right. Then back. So here is 3f. It's the limit. X goes to infinity of 3x plus 5 over 2x times the square root of x plus 5x minus 1. So if we plug in, on top we get infinity, on the bottom we get infinity. That means we do more. It's just like 0 over 0, infinity over infinity is an indeterminate form. You have to do more work. When you have limits to infinity of powers of x over powers of x, our usual go-to method of dealing with this is to divide everything by the highest power of x in the denominator. Which is what? It's actually higher than 1. So it might help if we rewrote it. So what I really have in the bottom specifically, x times the square root of x is x times x to the 1/2. And x times x to the 1/2 is x to the 1 times x to the 1/2. And we add those powers, and 1 plus 1/2 is 3/2. That's your biggest power in the denominator. You've got 2 times x to the 3/2 plus 5x minus 1. And now you might be able to get rid of just saying the answer is 0, because we know that when you have a limit as x goes to infinity of a rational type thing like this, where the bottom thing has a bigger power than the top thing, the bottom thing is growing faster, and so the whole fraction is getting smaller and smaller and smaller. But we can show the work as well. We divide everything by x to the 3/2. Actually, I will point out, I was thinking about this the other day. You can actually divide by x to the highest, how did I phrase this? Whatever the lower higher power is, meaning if your highest power in the numerator is smaller, you can divide by that highest power. Or if your highest power in the denominator is smaller, you can actually divide by that. Either one will work. I still just gonna go with denominator because that's what I've done all my life, all my calculus life. I'm gonna divide everything by x to the 3/2. So I've got 3x over x to the 3/2. That's 5 over x to the 3/2 over 2x to the 3/2 over x to the 3/2 plus 5x over x to the 3/2 minus 1 over x to the 3/2. And simplifying, we're just subtracting those powers. 1 minus 3/2 is negative 1/2, or 3 over x to the positive 1/2. That doesn't change. X to the 3/2 over x to the 3/2 cancels, you get 2. 5x over x to the 3/2 is just 5 over x to the 1/2. And then each of these things where you've got division by something that's getting larger and larger and larger, if x is going to infinity, x to the 1/2 is also going to infinity, and 3 divided by that is going to 5 divided by something infinitely large is getting closer and closer to 0. So is that. So is that. So we're left with 0 plus 0 over 2 plus 0 plus 0. 0 divided by not 0 is totally fine. It's 0. This limit is 0. More generally, though, you have a limit to infinity, and the denominator has a higher power of x than the numerator, we know the answer is going to be 0. Just to kind of clarify, if instead I'd said, what's the limit as x goes to infinity of 2x cubed plus 5x plus 1 over 9x cubed plus 4x squared plus 5, you would still need to show work, in my opinion, but I expect you all to tell me that the answer is what lovely fraction? Right, 2 over 9. Because the powers, the degrees are the same, so the limit's going to be the limit of the leading coefficients, as long as it's x going to plus or minus infinity. It wouldn't be true if it was x going to 3. All right, so definitely don't let her trick you. She could ask you something like this. Limit as x goes to 3 of 2x cubed plus 5x plus 1 over 9x cubed plus 4x squared plus 5. And if you're not being careful, you might be like, oh, the answer is 2/9. Really, the answer is 2 times 3 cubed plus 5 times 3 plus 1 over 9 times 3 cubed plus 4 times 3 squared plus 5. And I don't know what that is, and I'm not going to do anything more with it, and neither should you, but I am going to circle it or box it and be like, there's my answer. There's going to be something uglier than this. Like every one of those practice tests had something where it was like the limit is x approaches something dumb of some weird looking function, and the idea was just you plug it in and you get a number and don't simplify it at all. Like, which one on here? I just want to see it just as like this. No, that one's weird actually. Is this test the only one that doesn't have one? Yeah, you're right. It's C, yeah. I was just worried you're gonna get no, yeah. So C, right? Totally bonkers looking. But if you plug in -1, you get great. Cosine of 0 minus 8 times -1 is something. Cosine of 0, you could say is 1, whatever. And then the bottom is natural log of 1 plus tangent of -1. And that's also something. And we would just leave it like that. I should say those are both something that are not 0. And so if you do this one, I'm just going to write cosine of 0 minus 8 times -1 over natural log of 1 plus tangent of -1. I'll point out that this one is slightly annoying because technically you could simplify it a little bit. If you really, really wanted to, you could say cosine of 0 is 1. You've got 1 plus 8. Natural log of 1 is 0. I don't know what tangent of -1 is, and you shouldn't know what it is. No one should know what that is. But it's something. It's something that's not 0. So that's it. That's your answer. I guess I could say it's 9 on top, but you should really just leave it like this, though, I think. That's what I would do. And then if you have time at the end, come back and simplify things you want to simplify. But if you don't, this is a perfectly legit answer. The only thing you have to be sure of in your mind is it's not 0 over 0. So you do have to know that tangent is -1. Okay. Other questions? I feel like Dana, you had another question. Yes. 3F. There's lots of limit problems for sure. I mean, there's literally each of these had 7 limit problems. So limits are going to be a big part of this test tomorrow. So let's see, 3F here. The limit as x approaches 5 from the left, x plus 4 over x minus 5 cubed. Oh, sorry, maybe I'm looking at the wrong one. Apologies. Oh, yeah, you're right. I got the wrong one. I am so sorry. 3, 3, 3. There we go. While we're here, though, we might as well look at this one for just a moment. So if I plug it in, what do I get? What do I get on top? So be careful. I want to be, this is for sure going to come up. Am I approaching 5? Am I approaching -5? Definitely 5. Positive. I'm approaching positive 5. What side am I approaching positive 5 from? The left side. So be careful, right? We are approaching positive 5. From, I don't actually care right now what side I'm approaching it from. If I was doing this limit from the get-go, I would ignore that completely. Like, okay, I'm approaching 5. I'm going to plug in 5. Plug in 5, what do I get? I get 5 plus 4 over 0 cubed. And now what do I see? I see not 0 over 0. And I have come to learn that when it's not 0 over 0, we either get what kind of answer? What's one possible answer? Right, what's another possible answer? Right, and actually if it's one side of those are only 2. If it happens to be a double-sided limit, then it could be does not exist because one side will go up and one side will go down. Like it would here. But if it's a one-sided not 0 over 0 limit, you got 2 choices, infinity or negative infinity. Your only job at this point is to determine what the sign. So we're approaching 5 from the left. Now it matters. Now this 5 from the left matters. That means we are a little bit less than positive 5. Which means the insides of this parentheses are a little bit negative. Or left of 0, if you prefer left of 0. And then the negative number cubed, still negative. So overall, this is going to be positive divided by negative, which is negative. That's our answer. Yeah. Exactly, yeah. So if the question was just limit as x approaches 5 in general of this thing, well, I would do the left-hand side. Now, honestly, what I would say really is, I know if that power is odd there on the thing that's 0 in the bottom, it's going to be non-existent because they're going to get opposite things. But the work I would show would, yeah, to do the left-hand side, then also to do the right-hand side. And we can see here, when we do the right-hand side, we're going to get the same result, except now we're going to get 9 on top and a very slightly positive 0 on the bottom, which is going to give me a positive divided by a positive, which is a positive infinity. And then, since the left and the right-hand side don't go towards the same infinity, this does not exist. Exactly. Okay, but now to go on to the other actual question that was asked, which is midterm. Sorry, there's so many practice midterms. This one, is it that one? Yep, 3. Okay, you said 3F. Oh yeah, ooh, interesting. Yeah. This one, cosine of 3x minus 1 over 2x squared. Good times. Okay, so this one I feel like is extra tricky. Kind of, yeah, it's extra tricky. Yeah, my papers are all over the place here. Sure, we'll find later. That's today. Yeah, sure. Okay, so limit as x approaches 0 of cosine of 3x minus 1 to 2x squared. Whatever you see, cosine of something minus 1 or 1 minus cosine of something. Well, actually, I should back up. What should I do first? Plug it in. You plug it in, you get cosine of 0 minus 1 over 0. And you do need to know here that this ends up being a 0 over 0. If it was a not 0 over 0, you would be like with some sort of infinity, just like the previous problem we did. But here, cosine of 0 is 1. 1 minus 1 over 0 is 0. So do stuff. In particular, when you see cosine minus 1 or 1 minus cosine, the stuff we do is multiplying by the conjugates. It's kind of the only way to deal with it. So we're going to do the limit as x approaches 0 of cosine of 3x minus 1 over 2x squared times cosine of 3x plus 1 over the same cosine of 3x plus 1. And then just like every time when we multiply by the conjugates multiply out in a way where you get the first thing squared, the middle terms cancel, minus the second thing squared. So on top, we're going to get cosine squared of 3x minus 1 squared, which I'm not going to write. I'm just going to write 1. 1 squared is 1. On the bottom, we almost never multiply out the things that are not conjugates. So leave it as 2x squared times cosine of 3x plus 1. Now, here's what makes this one a little extra tricky. There's a trig identity up there, but it's a little dicey. So here's what I'd recommend. If you're not sure about the trig identity, write this down. I know sine squared of whatever angle I'm dealing with plus cosine squared of whatever angle I'm dealing with is equal to 1. So then I would really love to get cosine squared of my angle minus 1. So I'm going to subtract sine squared. So that cosine squared theta is equal to 1 minus sine squared theta. And then subtract 1. Cosine squared theta minus 1 is equal to negative sine squared of theta. Where theta is whatever angle we've got. In this case, theta is 3x. So that's what's this is going to get replaced by. This cosine squared of 3x minus 1 is going to end up equaling negative sine squared of 3x. Okay, so we're just going to rewrite it. We're going to equal the limit as x goes to 0 of negative sine squared of 3x over 2x squared times cosine of 3x plus 1. And now we're in a very specific situation that I recommend dealing with in a certain way. I've got sine of 0 over some zeros. And I know that when I have sine of a thing, I really want the exact same, I should say, when I have sine of a thing that is going closer and closer to 0, I want the exact same expression underneath it. Here's what I recommend. We'll do a couple more of these after we do this one. Oh, wow, time is really flowing by. So this is gonna be the limit. X goes to 0. I'm gonna write this as, no, I don't really want the, I'm gonna put the negative one out in front. And I want a sine of 3x. And another sine of 3x. And I'm just leaving, I'm writing those at the top of a fraction, which I'm gonna fill in underneath in a second. And then I also have all this other stuff in the denominator, 2x squared times my cosine of 3x plus 1. I should mention, this is not the only way of doing this, it's just the way I think works pretty well. So now, what do I wish I had beneath sine of 3x? 3x. But if I divide by 3x, I have to multiply by 3x. What do I wish I had beneath that other sine of 3x? Also with 3x. And then you went up here as well. Okay, the x here and the x here give me an x squared, and those x squareds cancel out the x squared we're dividing by there. Now, the important question, what is the limit as x goes to 0 of sine of 3x over 3x? 1, right? That's why we did that, because when you have the limit as x goes to somewhere of sine of something over the same something, and those somethings are going to 0, that limit's going to be 1. So I would encourage you, if you're doing a problem like this, to write out the next step as I am doing it right now. I would say this is equal to -1 times 1 times 1 times 3 times 3 over 2 times cosine of 0 plus 1. Just to show that you really know what's happening. And then simplify it. -1 times 1 times 1 is -1. 3 times 3 is 9. So you get -9 over 2 times 2. This cosine of 0 is 1. End up with -9/4. That's how I would approach this type of problem. Let me show you another example like this, just to kind of help you out. At least, because I have to imagine there's going to be some sort of sine or cosine problem like this. So if you see a limit, a 0 over 0 type of limit with a cosine -1 or a 1 minus cosine, you first have to multiply by it. But if you see a 0 over 0 limit where it's just like sine of some stuff over some stuff, like the limit as x goes to 0 of sine, sure, cubed of 5x over 2x cubed. The answer is not 5/2. And even if it was, you would still need to show the work about how you got there. If someone wrote whatever the right answer was here, I wouldn't accept it really if they didn't show me that they knew what they were doing. So here's the work I would want to see. I'm going to write this as, how many sines do I have multiplied together? 3 of them. The sine of 5x times sine of 5x times sine of 5x. Some people like to do something slightly different, and like take the x's from the x cubed down there and put them in the denominators there. It's kind of slicker, but I feel like it's an easy way to make a mistake. So I'm going to be careful. Safety's fun. Write 2x cubed over there. And currently, this expression is the same. I haven't changed anything. I've just written it in a really awkward way. And now I'm going to fill in the parts I need to fill in. Of course, beneath sine of 5x, I want 5x. Beneath that sine of 5x, I also want a 5x. And beneath, so I put one up there. And beneath that one, I also want. And I would try to do as little writing as possible on this problem, right? You're trying to move quickly through this exam. So I would probably do something like circle these, say those cancel. And then I'm left with 1 times 1 times 1 times 5 times 5 over 2. So 125 over 2. The thing I want you to not have a problem with is we are not saying that sine of 5x over 5x is equal to 1. We're saying its limit as x approaches 0 is equal to 1. So when you go from this step to this step, you have to not write the limit and just say, oh yeah, the limit of that is 1. Limit of that is 1. Limit of that is 1. And all this other stuff is just. All right. Other things? I've got other things I can say. Ooh, yeah. I'm gonna If you really have something, raise your hand, let me know, but I definitely have a few things I want to say in the last 10 minutes. So, few things. Thing one, where'd you go? Thing one. Oh yeah, that, okay. So many things. Limits of sequences. So you're definitely gonna see one where it's like the limit as n goes to infinity of I squared to the n over 7 to the n. And I really think what your teacher would like you to do is to write it all as one fraction to the nth power. So not that you have to, but I think it's easiest to see what's happening if you write it like this. Here's the question. Is that fraction bigger than 1 or less than 1? Well, I'm trying to make it a little tricky. Is pi squared bigger than 7 or less than 7? Definitely bigger, right? Because pi is bigger than 3, so pi squared is definitely bigger than 7. So that fraction is bigger than 1, and you're multiplying the thing that's bigger than 1 by itself over and over and over. That fraction is getting infinite, or that expression is getting infinite. So this limit's going to be infinity. And you can say because pi squared over 7 is bigger than 1. To me, that's a good enough reason. On the other side of things, ooh, yeah. What if we had something like the limit as n goes to infinity of 2 to the n plus 3 over, sure, negative e to the n minus 1. The plus 3 and the minus 1 do not matter. We should deal with them by getting rid of them, meaning rewrite this as 2 to the n over negative e to the n times 2 to the third over negative e to the negative 1. This part here doesn't matter, except it matters in that it still needs to be there so that it's the same expression as you had before. But it doesn't matter as far as what this limit is going to be, because that's just a constant. It's, I don't know, negative 24 or something. Here, I have, again, I would really like to write this as just one fraction, 2 over negative e to the nth power. Kind of done. So now, don't pay attention to the sign. I know it's negative, forget that it's negative. Is 2 over e bigger than 1 or less than 1? Right. So I would say 2 over e is less than 1. Or more importantly, negative 2 over e in absolute value is less than 1. And if your fraction is less than 1 and you multiply it by itself over and over and over again, it gets smaller, smaller, smaller. So this limit's going to be 0 because of this fraction being less than 1. Yeah. Typically, you don't get asked, like, not that we can just that. I just want to point out, usually you're not being asked when n is going to negative infinity. You could be, I suppose. Right. So yeah. Yeah. Give me like a minute, but yes, we can look at that in 1 second. So I just wanted to, on the flip side here, if instead we had the limit as n goes to infinity of negative e over 2 to the n, now you've got something that's more negative than negative 1, right? The absolute value of negative e over 2 bigger than 1. And this is the case that I never love because the limit doesn't exist. Because this fraction is getting bigger and bigger and bigger, but it's alternating. And just to be really screwy, if on the other hand, someone said, what's the limit as n goes to infinity of negative e to the n over 2 to the n? Well, now that answer is negative infinity, because the e to the n over 2 to the n is still going to infinity, and you've just got a negative 1 out in front. So for these sequencey type ones where you've got something raised to the nth power, basically the question is the stuff being raised to the nth power bigger than 1 in absolute value or less than 1 in absolute value? If it's less than 1, it's going to go to 0 because it's getting smaller, smaller, smaller. bigger than 1, it's either going to blow up to some sort of infinity, or if it's alternating back and forth between positive and negative things every other term, that's when you have to then say the limit doesn't exist. Yeah, we got time. We got time. So, question. Yes. Well, so divergent, you can't find the limits because it's divergent. It will almost always be convergent. In fact, I'm running out of time. Let me give you an example. Let's say we have this convergent recursive sequence. Sorry, Lila, I know you asked a question. I'm trying to conjure up an example in my brain here. Let's say we have this, the convergent sequence where a sub n plus 1 is equal to 1/5 times 4 a sub n plus 16 over a sub n. We are told it converges. Our job is to find what it converges to. And your job is to take every a sub whatever and replace it with L. And be careful, there was one example where it was like a sub n plus 1, and the plus 1 wasn't part of the subscript. You're only replacing the a sub whatever with L. Anything after that is still there. So here, we're going to have the equation L equal to 1/5 times 4L plus 16 over L. And while you're welcome to do this in whatever way you want, I would encourage you to try and do it in the way that is the easiest. I don't like that 1/5. Multiply both sides by 5. Great. Cancel, cancel. Now I've got 5L equal to 4L plus 16 over L. Subtract 4L from both sides. There are certainly other ways to do this problem, but this way I think is the easiest. I have L equal to 16 over L. Multiply both sides by L, and you get L squared equal to 16. You get L equal to plus 4 or minus 4. But only one of those can actually be the limit. Oh, and I forgot to give a crucial piece of information. Apologies. Where did I write that down? We are starting with a sub 1 equal to 2. Could the limit be -4? Definitely not. And here's why. It's almost never going to be. But it could be, so don't just assume it's not the -1. If you start with 2, 4 times 2 plus 16 divided by 2, still positive, right? Take a positive number, multiply it by 4, add 16 divided by it. There's nothing that made any of those things negative. So once you start positive, you are stuck being positive. And if you're stuck being positive, it can't be -4, it's got to be. You could probably, in some sort of way, make a similar argument to yourself when you have a question like this. That you're going to get potentially 2 different limit values. Only one of them can ever be the right choice. And will probably be the positive one. But you should think about, if you plug in the first value, what kind of thing you get back next. Yeah, it's 258. Okay. So, Lila, you had a question about like if you had something like e going to negative infinity, right? Was it like an e to the something kind of question? Yeah, something like maybe the limit as x goes to negative infinity of e to the 2x plus e to the x over, sure, e to the 3x plus 4. I have no idea what's going to happen here. Here's what I know. If I were doing this limit instead, I would divide everything by the thing that got the biggest, the fastest, which would be e to the 3x. So here, I would divide everything by e to the 3x. That's the thing that's going to be biggest, the fastest. On the other hand, when you're going to negative infinity, roles are reversed. The thing that's, nothing's really getting big. Actually, this one you can totally do without doing any work. Because here's the thing. Yeah, it's 3 o'clock. Okay, sure. Here's what e to the x looks like. As x goes to infinity, what happens to e to the x? Goes to, right, but as x goes to negative infinity, what happens to e to the x? Right, so you could actually here get a saying that's going to be 0 plus 0 over 0 plus 4. Now, I probably made this one slightly too easy, so let me just show you. If instead, I would say like, I know it's 3, but just let me give me one more minute. Instead, we have this e to the 2x plus e to the x over e to the 3x plus e to the 4x. Yeah, I would divide everything by e to the power that is the smallest. I will point out here you'd have 0 plus 0 over 0 plus 0, which is not good. It's more work. So here I think I would divide everything by e to the x. I hope. We'll find out. It might not work. We'll find out. We'll divide everything by e to the x. Well, yeah, it's kind of dicey, but it'll be okay. I probably should have picked the thing that's biggest in the denominator, right? Those are good rules to live by. Because here what's going to happen is I'm going to get 0 plus 1 over 0 plus 0, which is not 0 over 0, which is maybe the. So what I should have actually said, I should have gone back to the usual thing, which is divide by the thing that's getting biggest the fastest. It's in the denominator. Okay. Which is not e to the x, it's e to the what? It's not an easy question to answer. It's e to the 3x. Because we're not going to the right, we're going to the left. So the roles are reversed. Normally, as x goes to infinity, e to the 4x would grow the fastest. But if you're going to the left, things are reversed, and e to the 3x doesn't grow the fastest, it decreases the most slowly. Right? It is shrinking the least fast, I guess, is the best. So I would divide everything by e to the 3x. And again, apologies for taking extra time here. I really want you to see this. And if we did that, we would get the limit as x goes to negative infinity of, I'm a little worried about this actually too. Yeah, e to the negative x plus e to the negative 2x over 1 plus, that seems like, I feel like I've really blown it there. Maybe I'm totally wrong about how these problems are not good. I'm making a bad problem. I'm sorry. Yeah. Man, I don't love it. 0 plus 0 over 0 plus 0. You divide by that. 0 plus 1. 0, 0. I guess I picked one that goes to infinity, so it's just hard to kind of see what's happening as a problem. Yeah. I guess my initial intuition was the right one. I just don't like it. So there was a better problem in her actual exam, but I should let you all go. So I will write something about this and post it on Canvas before tomorrow, just so you all have, so I can be more clear. But I can't keep you any longer because it's 3:03. Maggie.